The journey begins in the vast tropical banana plantations, where harvest leaves behind millions of heavy stems.
Farmers harvest the fruit bunches and cut down the massive pseudostems, which are often considered agricultural waste. Usually, these waterlogged trunks are left to rot on the ground, releasing greenhouse gases into the atmosphere. However, this modern supply chain collects the fresh stems immediately to transform them into valuable industrial fiber.
The cross-section reveals concentric layers of sheath, which contain strong natural fibers hidden within the fleshy pulp.
Heavy trucks transport the raw material to the processing facility before the stems begin to lose moisture.
Upon arrival at the factory, the stems are unloaded onto a conveyor belt for the initial splitting.
Workers feed the logs into a mechanical splitter that slices them lengthwise into manageable long sheath strips. These layered strips travel along a conveyor belt towards the decorticator machine for the fiber extraction process. Operators feed the strips into the raspador, where high-speed rotating blades scrape away the pulp and water. The blades mechanically separate the green fleshy matter from the strong, white cellulose fibers inside the sheath. The nutrient-rich pulp waste falls into a collection trough to be converted into organic liquid fertilizer later.
Long strands of raw white fiber emerge from the machine, dripping with sap and needing immediate washing.
Workers hang the wet fibers on racks where high-pressure water jets remove the sticky residual plant sap. The washed fibers pass through a roller press to squeeze out excess water before the drying stage. The clean fibers are hung in a solar drying greenhouse to naturally evaporate moisture using sunlight energy. Over several hours, the fibers dry completely, turning a brilliant white and regaining their natural tensile strength.
Workers bundle the dried fibers into large bales, ready for the secondary processing into soft, absorbent pulp.
Forklifts transport the bales to the sanitary pad production wing, where hygiene standards are strictly controlled.
The rough fibers are fed into a carding machine that combs and detangles them into a soft wool.
This mechanical process separates the individual strands, making the material fluffy, airy, and highly absorbent for liquids. The fluff passes through a steam sterilization chamber to ensure it is pathogen-free without using harsh chemicals.
A small percentage of organic cotton is blended with the banana fiber to enhance softness against skin. The blended material is airlaid onto a moving belt to form the thick, absorbent core of the pad.
Rollers compress the fluffy layer to the precise density required to lock in fluid and prevent leakage.
A biodegradable barrier film is applied to the bottom to prevent fluid from passing through to clothing. A soft, non-woven top sheet is placed over the absorbent banana core to ensure user comfort. Ultrasonic sealers bond the three layers together at the edges without using any toxic chemical glues. A precision die-cutting machine stamps out the final pad shape, including the wings for secure attachment.
The excess trim waste is vacuumed away and recycled back into the beginning of the core formation process.
Automated nozzles apply a thin strip of food-grade adhesive to the back of the pad for fastening. A silicone-coated release paper is placed over the adhesive to protect it until the product is used. Mechanical arms trifold the pads into a compact square shape, making them discreet and easy to carry. Each folded pad is wrapped in a biodegradable pouch to maintain sterility and hygiene until the moment of use. A small sticker seals the pouch shut, ensuring the product remains clean and protected from the environment.
The individually wrapped pads travel down the conveyor belt to the grouping station for final retail packaging.
Sensors count the moving units and group them into precise stacks of 10 for the standard retail pack.
The stacks are pushed into recycled cardboard boxes, eliminating the need for single-use plastic outer packaging.
The filled boxes pass through a final UV light tunnel to sterilize the exterior surface before shipping. A sensitive metal detector scans every box to ensure no machinery fragments have accidentally contaminated the product.
In the laboratory, quality control inspectors randomly select pads to test for absorption speed and retention capacity.
Standard blue liquid is poured onto the pad to verify that the banana fiber core locks moisture instantly. Cutting the test sample reveals that the liquid is trapped deep inside, keeping the surface layer dry. Technicians weigh the samples to confirm they meet the strict absorbency standards required for menstrual hygiene products.
That compostability tests ensure the pad will decompose naturally within 6 months, unlike traditional plastic-based sanitary pads.
Laser coders print the batch number and expiration date on every box for traceability and consumer safety.
The boxes are sealed with paper tape, maintaining the commitment to a 100% plastic-free product.
Workers stack the finished boxes onto wooden pallets, preparing them for distribution to pharmacies and stores.
The pallet is wrapped to secure the load, ensuring the boxes remain stable during transport to the warehouse. Forklifts move the pallets to the storage racks, ready to be shipped out to meet growing market demand. Back at the extraction unit, the liquid sap collected during processing is diverted to a separate tank.
This nutrient-rich sap is processed into a potent organic liquid fertilizer that is returned to the farmers.
Farmers spray this liquid gold back onto their crops, creating a perfect circular economy within the industry. The edible central core of the stem is also saved and packaged as a nutritious vegetable food source.
The factory provides vital employment opportunities for local women, empowering them with financial independence and technical skills.
Regular training sessions ensure that all employees are skilled in operating the advanced machinery safely and efficiently.
The entire manufacturing facility is powered by rooftop solar panels, drastically reducing the carbon footprint of production. An on-site treatment plant recycles the water used for washing fibers, minimizing the impact on local resources. Microscopic analysis shows the porous structure of banana fiber, which gives it superior absorption compared to cotton.
Unlike plastic pads that release toxic fumes when burned, banana fiber pads turn into harmless organic ash.
The affordable pads are distributed to rural communities, improving menstrual hygiene management for thousands of women and girls.
Educational workshops accompany the distribution, breaking taboos and teaching young girls about health and environmental sustainability.
Beyond pads, the versatile fiber is also woven into durable textiles for making bags, mats, and clothing.
The pulp can even be used to manufacture high-quality, tree-free paper, further diversifying the use of waste.
Skilled technicians perform regular maintenance on the extraction machines to keep the blades sharp and efficient.
At the end of every shift, the production area is thoroughly sanitized to maintain pharmaceutical-grade hygiene standards. Delivery trucks load the finished cartons, carrying the eco-friendly solution to supermarkets and pharmacies across the country.
On store shelves, the product stands out as a sustainable alternative to conventional plastic-based hygiene products.
Conscious consumers choose the brand for its environmental benefits and its support of local banana farmers.
Back at the farm, farmers now receive additional income for stems that they previously paid to discard. The cycle continues as new shoots emerge, ensuring a renewable supply of raw material for the future.
Banana plants grow rapidly, reaching maturity in just 9 months, making them a highly sustainable fiber source.
This facility proves that industrial processing can coexist harmoniously with nature, reducing waste rather than creating it.
The finished pad is soft, white, and indistinguishable from standard products, yet carries zero environmental guilt.
After use, the pad can be composted at home, returning nutrients to the soil within 6 months.
Engineers constantly optimize the machinery to consume less energy while maintaining the high quality of output.
Research teams continue to innovate, developing new ways to utilize every part of the banana plant. Experiments are underway to spin the fiber into fine yarn that could rival silk in the future. Artisans also use the coarser fibers to create beautiful handicrafts, adding another layer of value to waste. The success of this model has led to exports, sharing this sustainable hygiene solution with the world.
For the workers here, this factory represents more than just a job. It is a community lifeline.
As the sun sets over the plantation, the positive impact of this innovation resonates through the ecosystem. The factory continues to hum through the night, processing the endless supply of stems from the harvest. This closed-loop system demonstrates that industrial manufacturing does not have to come at a cost to nature. Replacing plastic pads with banana fiber significantly reduces the amount of non-biodegradable waste in our landfills.
Access to affordable, eco-friendly hygiene products keeps girls in school and empowers the next generation of leaders.
The certification mark guarantees that no harmful chemicals or bleaches touch the sensitive skin of the user. Lightweight, breathable, and strong, banana fiber is truly one of nature's most overlooked engineering marvels. Collaboration between agriculture and industry creates a powerful synergy that drives economic growth and environmental stewardship.
As the final truck is loaded, the facility prepares for another day of turning waste into wealth.
From the field to the factory, and finally to the consumer, every step is optimized for sustainability.
It is a reminder that the solutions to our modern problems often lie hidden within nature itself.
This model of agro-industrial processing serves as a blueprint for a greener, more sustainable industrial future.
The humble banana plant provides food, fiber, and fertilizer, proving its worth as a miracle crop.
Achieving zero waste production is not just a goal here, it is a daily operational reality.
This concludes our journey inside the engineering marvel of the modern banana stem and sanitary pad factory.
If you enjoyed this documentary, please subscribe to our channel for more insights into sustainable manufacturing.
Click the video on the screen to discover how other agricultural waste is transformed into valuable products.
We thank the farmers, engineers, and workers who opened their doors to make this film possible.
Thank you for watching, and join us next time as we explore more innovations in green technology.